Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. In the last episode, we used Autodesk's FBX SDK to read FBX files and import any geometry that they might contain. In order to do so, we traverse the node tree that represents a scene in FBX, and if a node is a mesh or an LOD group, then we read the vertex and index data using the API functions provided by the SDK. Today I would like to work on the editor and set it up to use our FBX importer code and import geometry assets. As I mentioned in the intro of this video, we traverse a node tree to look for meshes and LOD groups. However, I made a mistake in the getScene function, which I wrote in the last episode, and I'd like to correct that mistake before moving on. In this part of the function, we need to move out this if statement in order for it to make sense. At the end, if this node is not a mesh or an LOD group, we call getScene again to check the remaining nodes, and we do the same at the end of getMesh function. Now let's close all files and go to the editor and see what we need to do to be able to use this code. So what I'd like to have is the ability to import any type of content by simply dropping the files onto the content browser. For example, here we have an FBX file, and of course when I drop it onto the content browser, nothing happens. So the first thing to do is to make the content browser accept dropped files and use some helper methods to examine if a file can be imported, and if so, do the import. To allow items to be dropped in the list view of the content browser, we can set a property that's called allowDrop to true. However, instead of setting it to true, I'll bind it to the same property of the content browser, so we can make this into a configurable functionality for anyone that uses the content browser. When dropping items is enabled, we can handle any drop events by writing an event handler. When using Windows File Explorer to drag and drop files, the drag event args data property will contain a payload with file names that are being dragged. To check if that's indeed the case, we call getDataPresent with dataFormats file drop. So if there is a selected folder, which is always the case except when we don't have a project opened, and there are files being dropped, we get the array of file names and call an asynchronous helper method that will import the files if possible. We also set e.handled to true to prevent the event from propagating any further. Let me move this event handler up a little and implement the helper method that imports the files. This is a static asynchronous method which takes an array of file paths and a destination path where the files are going to be saved. Like always, I wrap the file I/O operations in a try-catch block. Before we start importing any files, we need to disable Content Watcher events to avoid unnecessary updates to Asset Registry and Content Browser. When we are done importing files, we enable Content Watcher events again. Putting that in a finally section will make sure the events are enabled regardless of any errors that might have occurred. Then for each one of the files, we start a task on the thread pool that will asynchronously call another import method which does the actual importing, and we wait for all those tasks to complete before returning. In this import method, we check if the file that we are supposed to import is a directory, and if so, we'll return. Otherwise, we prepare the data such that we can have access to the file's name, extension, and a valid destination folder. Then, depending on the file's extension, we create an asset of the type that can import the file. Spoiler alert, these are the file types that I plan to support for importing. In case of an FBX file, we create a geometry asset which will be in charge of importing it. At the end, if we have got a valid asset, we can use yet another import method to import the file. Here, we construct the full path where the asset file will be saved. Then we call the import method from the asset base class, which I am going to add in a second. And finally save the imported asset to its destination. Now let me add an abstract import method in the asset base class, which all classes deriving from it need to implement. Here we see that we need to implement the import method for the geometry asset class. First, we get the file extension and also remember where it came from using source path property. Then, if we got an FBX file, we are going to call ImportFbx, which I am going to write next. I'm checking the extension here again, because in the future we might want to support other file formats as well. So the file that we get here might not always be an FBX file. When loading an FBX file with embedded resources, like textures, the SDK will create a folder and unpack those resources into that folder. To avoid polluting the source location of the imported file, we first copy the FBX file to a temporary folder in our project and load it from there. Therefore, I'll add a new property to the project class which contains a path to this project's temp folder, with the temp folder being within the .primal private folder. When there is no temp folder, we need to create it first, and since this method is being called asynchronously, we need to lock this part of it to avoid trying to create the same folder using multiple threads. So let's add a lock object and create the temp folder within the scope of this lock. Now we can create a random file name and copy the FBX file to our temp folder using that name. I'm using random file names to avoid overwriting files that are already in the temp folder. This is because in theory we could drop files with the same names that came from different locations, and we wouldn't want them to overwrite each other in the temp folder. After copying the file, we finally call the ContentTools FBX importer function to read the file's content. Before adding the new API method to ContentTools wrapper, let's delete the temp folder when we close the project, so we don't end up with a pile of temporary files. Now let's import this function from the ContentTools DLL so that we can call it. Isn't it funny that we need to import a function that imports a file? I'm such a nerd. Anyway, this goes the same way as we already did for create primitive meshes, so we can basically copy and paste this code. However, now instead of calling create primitive mesh, we call ImportFbx function and change the error message for when it fails. Because I don't like to write duplicate code, let's refactor this into a single method and call that one instead. The only difference between these two methods is that they call different functions and have different failure messages. Everything else is the same. So the only parameters that we need are an action that generates the scene data and a failure message string. Now I simply call the action delegate and use the failure message, and we can rewrite these methods using a single line of code. Neat. One more thing before we test our code is to disable dropping files into the Save File dialog. That's because I don't want to import files using Save File dialog. And please welcome the first bug of today, which is we can't drop files into Content Browser because I forgot to set allow drop property to true. In the Content Browser views constructor, we enable dropping files by default. Now we can drop our files, but it failed to import. Inspecting the output panel, I see that we get a directory not found exception, so let's find out which directory it would be. Here I'm just stepping through the code and inspecting the contents of path variables. And here it is. Instead of using the temp file name, I accidentally used the folder path, which obviously is not a file name. Let's try that again. Now it's reading the FBX file, which is good, and it takes a minute because FBX SDK is slow in debug build. This time it failed to save. 3 times is a charm, they say, so let's fix our third bug. I'll set a breakpoint in the save method and try again. This all looks fine to me. I think this generate icon method could have something to do with it. We are running this code on a non-UI thread, so we need to be careful what we are doing here. First of all, we have got a constant for icon width, so let's use it here. We are creating this bitmap source on the UI thread because we need to access Geometry view to render to it. And then we are trying to read from the bitmap in this PNG encoder outside of the UI thread, which I think is the cause of our problem. I'll put it in the dispatcher scope and see if that helps. Congratulations! We successfully imported our first asset ever. Although it does look like the model that I am trying to import is split and saved into separate files. Okay, let me explain what's going on. Here is the model in Maya and you can see that it consists of different parts. By the way, this model is available to all my supporters on Patreon for all tiers. So feel free to go to my Patreon page and download it. It's the FBX file attachment, which you can click and hopefully it will download it onto your personal computing device. Now, because we have multiple mesh nodes here, our importer will assume that they are all separate objects in the scene and therefore saves each part to a separate file. I will improve the way we assemble meshes in the next episode, but for now let's just combine all the parts into one mesh and import it. I'll first remove the old asset files and then drag and drop the new file onto the editor. And there it is, all in a single asset file. Here is also proof that we can't drop files onto the Save File dialog. Let me also show you how much faster the importer is in release build. While building, I get these warnings about unused function parameters, so let's get rid of those first. Now let's import the file again. It took less than a couple of seconds this time. While timing different parts of the code, I found that most of the time is spent in the FBX importer rather than our vertex processing and packing code. And in the FBX importer, triangulating the meshes takes about 80% of the time. So that's yet another reason to triangulate meshes before importing them. It might simply be a lot faster. Anyway, this is it for today. We succeeded in importing meshes from FBX files and saving them into assets that can be used in the game project. Next time, I'm going to make a basic editor so that we can open and inspect the imported geometry assets. Hopefully you enjoyed watching this video, and as always, thank you so much for joining me, and I'll see you next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!